aleatory podcast.
Picture, if you will, a mountain lake. It is just utterly tranquil. The surface is like a sheet of polished obsidian, perfectly still, and it's reflecting the vast, unbroken blue of the sky above.
Right.
It's nestled deep in this lush valley, surrounded by really steep, dramatic cliffs and dense, vibrant green vegetation. If you were standing on the shore, you would hear birds singing in the canopy.
Just a completely idyllic scene.
Exactly. You'd hear the faint, rhythmic bells of cattle grazing on the rolling hills that gently slope down toward the water. It is the absolute picture of serenity, you know? The kind of place that feels ancient, untouched, and just completely at peace with the world around it.
Yeah, nature at its most peaceful.
But what if I told you that beneath that perfect, mirror-like surface, an incredibly violent, entirely invisible force was just waiting in the dark?
It presents a really profound and terrifying contradiction, doesn't it? I mean, we are so deeply conditioned by human history and biology to associate natural violence with loud, visual, undeniable chaos.
Like a hurricane or something.
Right, exactly. When we think of a natural disaster, we think of the Earth literally tearing itself apart during a seismic event. We think of the howling, deafening winds of a hurricane ripping ancient trees out of the soil by their roots.
Or a massive flood.
Or we picture a volcano dramatically spewing fire, ash, and molten rock into the stratosphere. We expect a warning, you know? We demand a physical manifestation of destruction that we can see, hear, and run from.
Yeah, we expect the threat to announce itself.
Right.
But this force offers absolutely no warning. It doesn't tear the trees from the ground. It doesn't crush the mud brick buildings or rip the roofs off homes.
It's completely silent.
It simply rises entirely silently, entirely invisibly from the tranquility of the water. And in an instant, it extinguishes every single breathing thing in its path.
Which is just, it's so hard to comprehend.
Imagine a force that can sweep through a densely populated valley and leave a delicate, fragile leaf perfectly intact on its branch, while simultaneously suffocating thousands of humans and animals in a matter of minutes. It is a ghost. A silent, invisible killer born from the most peaceful-looking environment imaginable.
Which really challenges our most fundamental understanding of nature's boundaries, I think. The idea that a body of water that we inherently view as a very source and sustainer of life can harbor a mechanism of mass, instantaneous death, and do so without leaving a single scratch on the physical landscape.
It's incredibly eerie.
It is deeply, viscerally unsettling. It forces us to pause and ask a much larger question for you, the listener. What else in our environment is quietly accumulating pressure, entirely out of sight, just waiting for the slightest, most trivial disturbance to release utter devastation?
Welcome to the episode. Together we turn knowledge into real results.
Yes, we do.
Today we are undertaking a truly monumental task. We are going to exhaustively unravel the science, the profound and tragic human toll, and the incredibly complex geopolitical aftermath of the deadliest gas disasters in recorded history. We are looking at the catastrophic limnic eruptions of Lake Manon and Lake Nyos.
And we really need to emphasize the gravity and the historical weight of what happened here. This is not just some quirky geological anomaly that scientists study in a lab.
No, not at all.
This is a story of a catastrophic, almost incomprehensible loss of human life. It is the story of a natural phenomenon that was entirely new to modern science at the time it occurred.
Brand new.
And perhaps most importantly, it is a stark documentation of human systems fundamentally failing to protect the most vulnerable in the wake of an unimaginable tragedy.
I want to start by laying out the timeline, because this didn't just happen once out of nowhere. There is a terrifying sequence of events here. We really have to go back to August 15th, 1984.
The first of the twin tragedies.
Exactly. We are looking at Lake Manon, which is a relatively small crater lake located in the northwest region of the West African nation of Cameroon. On this specific day in August, the lake suddenly erupts. It emits a lethal, completely invisible gas.
And 37 people die.
37 people. Just gone. But here is the part of the historical record that immediately caught my attention when preparing for this. The event was largely covered up by the authorities.
Right.
The surrounding communities, the innocent people who live, farm, and raise their families in the direct shadow of these beautiful lakes, are left entirely ignorant of the deadly danger they are sleeping next to.
Which forces us to ask a deeply uncomfortable question right out of the gate. Why? I mean, why on earth was an event that killed 37 people, essentially brushed under the rug by the government.
Was it simply a logistical failure? I mean, we are talking about 1984 in rural Cameroon.
Right.
Was it just a lack of basic infrastructure, no electricity, no phone lines in these remote areas to effectively spread the word to neighboring villages?
Infrastructure certainly played a role, yeah. But the historical consensus points to something more deliberate. Cameroon in the mid-1980s was navigating a really complex political landscape. While the authorities on the ground and in the central government were faced with a mass casualty event that they fundamentally did not understand. There was no clear enemy, no rebel uprising, no obvious disease outbreak.
Just a lake that supposedly killed people.
Right, just water. There is a strong argument to be made that the cover-up was a desperate attempt to maintain civil order, to avoid widespread, uncontrollable panic over a seemingly supernatural threat that the authorities had absolutely no capacity to explain, let alone prevent.
But the cost of that silence was astronomical.
It really was.
Because that lack of communication, that failure to warn the broader region, set the stage for what happened exactly 2 years and 6 days later. August 21st, 1986. We moved just 100 kilometers away from Manoun to another body of water, Lake Nyos.
Let's paint the picture of Lake Nyos for you. It is larger than Manoun. It's a crater lake, roughly a mile square, sitting high in a very remote mountainous area.
It's about 9:30 at night. The villagers in the surrounding communities, places with names like Nyos, Subum, Cha, and Fang, are settling in for the evening. The day's farming is done.
Families are in their homes.
Right, families are sleeping or getting ready for bed, and then, according to the few who survived to tell the tale, they hear a sound, a rumbling sound.
Yes. Survivors specifically noted a rumble that lasted maybe 15 to 20 seconds.
Now, when I read that, my first thought was an earthquake. Is that what they were hearing? The ground shaking?
Not exactly. While an earthquake could technically be a trigger, the sound they described wasn't the deep planetary groan of tectonic plates shifting. It was described as a more localized guttural rumbling, followed by a violent, churning, bubbling sound coming directly from the water itself.
One witness, who miraculously survived on a ridge overlooking the lake, described looking down through the darkness and seeing a massive white cloud rising directly from the surface of the water. And then a colossal fountain of frothy water shot straight up into the air.
Just massive.
We are talking 80 to 100 meters high.
Let's contextualize that height for a second. That is a fountain of frothy, violently churning water the height of a 25-story building, suddenly rocketing out of the center of an otherwise placid, silent lake.
That's horrifying, and the sheer force of that displaced water creates a massive 25-meter tsunami wave. A wave over 80 feet high that absolutely swamps the southern shore of the lake, stripping the rock completely bare of all vegetation and soil.
But as terrifying as an 80-foot wave in the dark is, the wave was not the killer that night. The true killer was what came out of the lake with the water.
The cloud.
The cloud.
The records indicate a sudden violent release of between 1.2 and 1.6 million tons of invisible gas. I had to look at those numbers several times.
It's almost unimaginable.
To put that into a spatial perspective, we are talking about roughly 1 to 1.5 cubic kilometers of raw gas erupting from the surface of this small lake.
And this is where the physical properties of the gas become the instrument of mass death. Because this specific gas is significantly heavier than the ambient atmospheric air, it does not dissipate upward into the night sky.
This doesn't just blow away.
It doesn't blow away on the breeze. It forcefully hugs the ground. It forms a dense, suffocating, completely invisible blanket that is roughly 50 meters thick, and it immediately begins to flow.
So it's not floating, it's pouring, like an avalanche.
Precisely. The fluid dynamics of this event are absolutely terrifying. It is behaving exactly like a highly dense fluid, a massive, invisible avalanche pouring over the crater rim.
And picking up speed.
Because of its incredible density and the steep mountainous topography, it travels down the valleys at sustained speeds of 20 to 50 kilometers per hour, with initial surges as it breached the crater rim likely reaching up to 100 kilometers per hour.
Wow. 100 kilometers per hour.
It is quite literally a tidal wave of suffocation moving silently through the darkness, invading homes, pooling in low-lying depressions, and completely displacing the breathable atmosphere.
The human toll is staggering to comprehend. 1,746 people, gone in a matter of minutes.
All region wiped out.
Over 3,500 livestock, like cattle, goats, sheep, wiped out. Birds dropped from the sky. Insects died in the grass. Every single breathing creature in the path of this 50-meter-high invisible river was simply extinguished.
Yet, as we mentioned right at the beginning, the physical destruction was non-existent beyond the immediate shoreline where the wave hit.
Right. The buildings and the villages down the valley were perfectly intact. The plans were completely fine.
I want to pause the narrative right here because we really must confront the horrifying implications of that timeline you laid out. We established that the Manaus disaster in 1984 was covered up.
Yeah.
If it hadn't been, if the Cameroonian government had immediately alerted the international scientific community, if they had educated the surrounding villages across the entire volcanic line about the warning signs, like the rumbling or the bubbling, could the 1,746 lives at Neos have been saved?
It's devastating to think about, because if you have absolutely no concept that a lake can suddenly erupt a deadly gas, your natural human instincts are entirely wrong for the situation.
You do the exact opposite of what you should do.
Right. If you hear a loud rumbling and a massive splashing sound coming from the lake at night, you don't run to high ground. You might actually walk toward the lake to see what's happening. Or you just stay in your bed assuming it's a landslide on the far shore.
Without knowledge, they were completely defenseless.
Exactly. Knowledge is the only defense against an invisible threat. And the selectivity of the devastation, the fact that humans perished while the flora survived, is something we need to unpack chemically to truly understand what this cloud was.
We do.
How does an invisible force target the mammalian respiratory system so violently, but leave a delicate leaf perfectly intact?
It comes down to the grim mechanics of asphyxiation. The cloud that erupted from Lake Nyos was almost pure carbon dioxide. From a biological standpoint, when the concentration of carbon dioxide in the air we breathe exceeds roughly 10%, it causes an incredibly rapid loss of consciousness.
So it's not a poison, per se.
It doesn't poison you in the traditional sense like cyanide. It essentially displaces the oxygen in the environment. It forces the oxygen out.
And plants, of course, respire entirely differently than mammals. They require carbon dioxide for photosynthesis.
Exactly. To a banana tree or a blade of grass, this massive rolling cloud of CO2 isn't a deadly poison. It is just an incredibly dense concentration of a compound they naturally process.
It's basically plant food.
But for humans, for cattle, for birds, inhaling that concentrated CO2 means the immediate systemic cessation of oxygen exchange in the bloodstream.
The sensory details reported by the very few survivors who were on the fringes of the cloud, or on slightly higher ground inside their homes, are harrowing. They provide vital clues to what happened.
What do they see?
Well, you have accounts of people waking up anywhere from 6 to 36 hours after the eruption. Can you even begin to imagine that?
36 hours.
Yeah. You go to sleep on a normal Thursday night, you lose consciousness, and you wake up a day and a half later in a village where every single person you know is dead.
The psychological trauma of that is beyond measurement.
Yeah.
But from a forensic standpoint, what did those survivors report seeing and feeling when they woke up?
They woke up to find their kerosene oil lamps had been completely extinguished, and importantly, they weren't blown out by a wind. They still had plenty of oil in the reservoirs. They simply stopped burning.
That's a huge clue.
The survivors also reported a very strong, lingering smell of rotten eggs, or in some cases, a smell like spent gunpowder. They reported feeling strange, warm sensations across their bodies. When they woke up, they suffered from violent, racking coughing fits, and many were vomiting blood. And perhaps the most visually shocking detail, when daylight finally broke and they looked toward the mountain, the formerly clear, pristine blue waters of Lake Nyos had turned a thick, muddy red-brown color.
Every single one of those specific details, the extinguished lamps, the mysterious smells, the physical symptoms, the violently discolored lake, they're all crucial pieces of forensic evidence.
How so? Walk us through it.
Well, the unburned oil lamps confirm the total, sustained displacement of atmospheric oxygen in the valleys. Fire cannot exist without oxygen.
Right. No oxygen, no flame.
And the muddy red lake indicates that deep, incredibly iron-rich waters from the absolute bottom of the lake were violently brought to the surface.
But how does water from the bottom make the lake turn red, though? I mean, dirt from the bottom wouldn't be bright red.
Because at the bottom of a deep, stagnant lake, the environment is anoxic. There is no oxygen down there. Iron exists down there in a dissolved state known as ferrous iron, which is actually clear.
Okay, so it's clear at the bottom.
But when that deep water was blasted to the surface and suddenly exposed to the oxygen in the atmosphere, that ferrous iron immediately oxidized. It turned into ferric iron.
Oh, wow.
Essentially, the entire surface of the lake rusted instantly upon contact with the air.
That is incredible. But what about the smells? The survivors clearly reported rotten eggs and gunpowder. My mind immediately goes to sulfur.
And you wouldn't be the only one. Those smells of rotten eggs and gunpowder strongly suggest the presence of hydrogen sulfide and sulfur dioxide. This was a massive red herring for the international teams of scientists who rushed to the scene.
Because when the first wave of investigators arrived, we are talking about prominent scientists like George W. Kling, William C. Evans, the French volcanologist Michel Halbwachs, and the Japanese researcher Minoru Kusakabe. They were walking into a profound geological mystery.
A total puzzle.
The fundamental question was this a bizarre volcanic eruption, or was it a natural phenomenon entirely new to modern science?
The initial debate within the scientific community was fierce. You have to look at the context. Lake Nyos is a crater lake, quite literally sitting in the middle of a known volcanic landscape, the Cameroon volcanic line.
So it's already a fiery neighborhood.
Exactly. So naturally, the first most logical assumption by many seasoned experts arriving on the scene was that they were looking at the aftermath of a phreatic eruption.
Walk me through that. What exactly is a phreatic eruption?
A phreatic eruption is a very specific type of volcanic event. It occurs when a pocket of superheated magma beneath the Earth's crust suddenly rises and comes into direct physical contact with a large body of groundwater or a lake.
Okay.
The extreme heat of the magma instantly flashes the water into steam. Because steam expands to over 1,000 times the volume of liquid water, it creates a massive, localized underground explosion that blows upward through the lake bed, carrying rock, ash, and volcanic gases with it.
Okay, so a classic, highly violent volcanic event. It sounds really plausible. A magma pocket hits the bottom of the lake, flashes to steam, blasts all through the water, and releases a cloud of volcanic gas.
It is entirely plausible on paper. But as Kling, Evans, and the rest of the team actually got out onto the lake in small boats and started taking physical measurements, the phreatic eruption theory began to completely fall apart. The data simply did not match the hypothesis.
What were the discrepancies? What didn't fit?
First and foremost, the temperature. If a massive pocket of molten magma had just blasted its way through the bottom of Lake Nyos 2 days prior, the residual heat left in the water column would be immense.
The water should have been boiling, or at least very warm.
Right. But when they lowered their temperature probes into the depths, the thermal profile of the lake was completely normal for a deep tropical body of water. There was no thermal anomaly whatsoever.
So no heat. What about the physical damage to the lake bed? If there was an explosion, surely there would be a crater at the bottom.
Exactly. A steam explosion would have churned up thousands of tons of mud, bedrock, and ancient sediment. But when they took sonar readings and core samples, the sediments at the very bottom of the lake were completely, utterly undisturbed.
Like nothing happened at all.
They laid in perfectly flat sequential layers. Nothing had blasted up through the floor.
And the third strike against the volcano theory was the chemistry, right? Despite all those survivor reports of smelling sulfur, the scientists found almost nothing in the water.
Right. In any normal volcanic eruption, the water would be heavily acidified and absolutely saturated with massive amounts of sulfur compounds. But the chemical analysis of Nyos showed virtually no sulfur.
So why did the survivors smell rotten eggs if there was no sulfur? Did they just imagine it?
The current understanding is that the massive physical upheaval of the lake water brought up deeply buried, decaying organic matter from the lake floor. Ancient plant material and algae that had been rotting in an oxygen-free environment for centuries. When that sludge hit the surface, it released volatile organic compounds that mimicked the smell of sulfur. Additionally, extreme concentrations of pure carbon dioxide can actually induce olfactory hallucinations or a burning sensation in the mucous membranes that a terrified, disoriented survivor might interpret as gunpowder.
So if there was no heat, no explosion from the lake bed, and no volcanic sulfur, what on earth happened? If the lake didn't erupt like a volcano, how did it release a cubic kilometer of gas?
To truly understand the mechanics of this disaster, we have to look very closely at the specific anatomical structure of Lake Nyos. It is not just a standard body of water. Geologically, it is what is known as a maar.
A maar, M-A-R. I've seen pictures of them. They look like perfectly circular punch holes in the Earth's crust.
That has a very accurate description. A maar is a broad, shallow relief volcanic crater created by a phreatomagmatic eruption centuries or even millennia ago. It's essentially a blast crater carved deep into the surrounding coarse-grained biotite quartz monzonite bedrock.
And because of how it was formed, Lake Nyos is incredibly deep for its relatively small surface area, isn't it?
Very deep. It goes down 208 meters.
208 meters deep. That is over 680 feet straight down. I'm trying to visualize the sheer weight of that much water.
We absolutely need to visualize it, because that water pressure is the key to the entire mystery. To understand how a lake can hold 1 million tons of invisible gas without anyone knowing, I want to use an analogy. I want you to picture a large, tightly sealed bottle of seltzer water or sparkling soda.
Okay, a sealed bottle of seltzer.
Limnologist scientists who study inland waters classify Lake Nyos as a meromictic lake. That is a crucial term. Most deep lakes in temperate climates like those in North America or Europe are holomictic.
Holomictic, meaning they mix.
Because they experience drastic seasonal temperature swings, freezing winters and hot summers, the temperature of the surface water changes. As water cools, it becomes denser and sinks, pushing the bottom water up. This creates a seasonal turnover.
Oh, I see.
The lake mixes itself every spring and fall, releasing any trapped gases slowly and safely into the atmosphere.
But Lake Nyos is in Cameroon. It is in an equatorial climate.
Precisely. It doesn't experience those extreme seasonal temperature swings. Because the surface temperature remains relatively warm and constant year-round, the lake remains fiercely, stubbornly, thermally stratified.
So it's layered.
It is divided into distinct horizontal layers that practically never mix. You have the upper layer, known as the mixolymian, which interacts with the wind and the atmosphere and supports fish and algae. And then, separated by a sharp, invisible density gradient called a chemocline, you have the deep, dark, cold layer at the bottom, the monomylian.
So the deep layer, this monomylian, just stagnates. It sits there entirely trapped beneath the upper layers year after year, century after century.
Trapped and under immense, crushing physical pressure. The hydrostatic pressure at 208 meters down is roughly 20 atmospheres. That means the water at the bottom of the lake is under 20 times the pressure of the air we are breathing right now in this room.
Wow. So we have our sealed seltzer bottle. The 20 atmospheres of pressure is the tightly screwed-on plastic cap. But where does the carbonation come from? If it wasn't an active volcanic blast, where did the gas originate?
Underneath the lake, buried deep within the Earth's crust, there is an ancient magmatic source. It wasn't erupting lava, but it was continuously, quietly leaking massive quantities of carbon dioxide gas into the surrounding groundwater.
Which then flows into the lake.
This gas-rich groundwater then seeped upward, feeding sublacustrine springs located at the very bottom of Lake Nyos.
So you essentially have a constant invisible feed of carbon dioxide entering the bottom of the lake. I've read estimates that it was flowing at a rate of roughly 4,400 tons of pure carbon dioxide every single year.
Yes. And because of those 20 atmospheres of crushing hydrostatic pressure, the gas doesn't just bubble up to the surface and float away. It is forced to dissolve completely into the cold water.
It just disappears into the water.
It stays in a state of aqueous solution, entirely invisible, just like the carbon dioxide gas is dissolved into the liquid of that unopened bottle of seltzer. As long as the pressure is on, the liquid looks perfectly still and clear.
Over decades, over centuries even, that stagnant bottom layer of Lake Nyos became completely supersaturated with this dissolved, invisible gas. It was a ticking bomb, quietly charging itself in the dark. The lake didn't erupt with lava. It didn't blast rocks into the sky. When the time came, the lake simply exhaled.
But using a word like exhaled paints a picture that is almost peaceful. I assure you, the fluid dynamics and the physics of how that exhalation actually occurred, an event technically classified as a limnic eruption, is anything but peaceful.
Right.
It is an incredibly violent, uncontrollable runaway chain reaction.
Before we get into the physical trigger that set off that chain reaction, I want to clarify one piece of the forensic puzzle. How did the scientists definitively prove that the gas in the lake was coming from magma deep underground?
That's a great question.
Why couldn't it have just been from millions of tons of rotting plant matter accumulating at the bottom of the lake over thousands of years? Doesn't rotting vegetation produce carbon dioxide?
It absolutely does, and that was a major alternate theory initially. But this is where the science of the investigation gets incredibly elegant. The team utilized highly advanced isotopic analysis. They specifically looked at the ratios of carbon-14 and the isotopes of helium, specifically helium-3 to helium-4.
Walk us through why those specific isotopes matter. Let's start with carbon-14. What does that tell us?
Carbon-14 is a radioactive isotope of carbon that decays over a known, predictable period of time. Biogenic carbon, which is carbon produced by rotting organic matter like dead plants and animals, will contain measurable levels of carbon-14 because it has a relatively young radioactive signature. It was alive relatively recently.
Okay, so it has a timestamp.
However, when the scientists tested the carbon dioxide dissolved in the deep waters of Lake Nyos, it returned a carbon-14 date of over 35,000 years.
Which means
Which means the carbon was, for all scientific intents and purposes, infinitely old. It had zero recent organic signature. It could not possibly have come from rotting leaves or dead fish.
and the helium, what role does that play?
The presence of helium-3 in specific elevated ratios is a definitive, unforgeable fingerprint of mantle-derived magmatic gas. Helium-3 is primordial. It was trapped in the Earth's mantle during the formation of the planet.
Oh, wow, so it's from the deep earth.
Finding it tightly bound with the carbon dioxide proved beyond a shadow of a doubt that the gas was coming from a cooling magma chamber, estimated to be up to 80 kilometers below the surface of the Earth, migrating up through the bedrock fissures and quietly dissolving into the lake.
Okay, so the bomb was built, the seltzer bottle was shaken, loaded with magmatic gas, and pressurized to its absolute physical limit. The water at the bottom was estimated to be up to 97% saturated with gas. It couldn't hold a single drop more.
It was incredibly unstable.
But what actually took the cap off? What was the trigger mechanism that caused a lake that had sat quietly for hundreds of years to suddenly explode?
This is perhaps the most frustrating part of the geological investigation because we run into the hard limits of historical reconstruction. We may never know, for absolute 100% certainty, what the exact trigger was on the night of August 21st, 1986.
It could have been anything.
The bottom layer of the lake was in such a highly precarious, critical state of supersaturation that the trigger didn't need to be massive. It could have been almost entirely trivial.
Let's debate the theories, though, because they range from the highly dramatic to the incredibly mundane. The most visually obvious theory is a landslide, right? When investigators arrived, they found a fresh, 80-meter-wide landslide scar on the steep rock cliff face directly overlooking the lake.
Yes, a rockfall. If hundreds of tons of solid rock suddenly detached from the cliff and crashed into the surface of the lake, it would create a massive downward kinetic force. That plunge of heavy rock could have mechanically pushed a volume of the deep, gas-saturated water slightly upward from its stable resting place.
But what if it wasn't a physical impact? Could it have been purely climatic? I noticed that both the Lake Monon disaster in 1984 and the Lake Nyos disaster in 1986 occurred in the month of August. In Cameroon, August is the absolute peak of the rainy season.
It is, and a severe meteorological event is a very strong candidate. Imagine a massive, sustained, unusually cold rainstorm sweeping over the valley. Hundreds of thousands of gallons of very cold, very dense rainwater pour onto the surface of the lake in a matter of hours.
And cold water sinks.
Because cold water is significantly denser than warm water, that chilled surface layer could have rapidly sunk through the water column, violently displacing the deep, saturated water and pushing it upward, causing a localized rollover of the lake layers.
I've also read theories suggesting it could have simply been strong, sustained winds blowing across the surface of the crater, generating internal standing waves, what limnologists call sitges deep within the lake.
That's a very real possibility, too.
The wind sloshes the upper layers back and forth, dragging the chemocline with it, until finally, a pocket of that deep, loaded water is lifted just slightly above its critical depth.
Any of those three, a landslide, a cold rain, or wind-driven internal waves, are highly plausible triggers. But frankly, the specific catalyst almost doesn't matter. What we really need to interrogate is the fluid dynamics of the eruption itself.
What happens next?
What exactly happens in the physics of the water column when that single deep parcel of supersaturated water begins to rise, for whatever reason?
It initiates a terrifying positive feedback loop. Let's walk through it slowly. Let's say, for the sake of the argument, a landslide pushes a chunk of that deep water up by just 2 or 3 meters.
Okay.
As that specific parcel of water rises, the immense hydrostatic pressure that was pushing down on it from above naturally decreases. It's exactly like slowly twisting and loosening the plastic cap on our shaken seltzer bottle.
Precisely. Because we are dealing with Henry's law of physics.
Break down Henry's law for us in this context. What does it actually mean?
Henry's law dictates that the solubility of a gas in a liquid is directly and inherently proportional to the pressure exerted upon it. High pressure means high solubility. The gas stays invisible in the liquid.
Okay, that makes sense.
Lower pressure means lower solubility. So as that parcel of water is pushed upward by the landslide and the crushing weight of the water above it lessens, the water can no longer physically hold all of that dissolved carbon dioxide in solution.
So what happens to the gas?
The gas literally exalts. It transitions out of solution and forms tiny, microscopic bubbles of pure gas.
And this is where the physics transition from a minor disturbance to a deadly, unstoppable event.
Yes. Because what do bubbles do in a liquid? They're buoyant. They inherently want to rise to the surface.
Right, so you have these newly formed bubbles rushing upward. And as they rise, they create physical friction. They drag the surrounding water up with them.
Exactly. This upward drag moves even more of that deep water to an even shallower depth. At this new, shallower depth, the pressure is even lower than before.
Which creates more bubbles.
This sudden drop in pressure causes more dissolved gas to instantaneously form bubbles. These new bubbles create more buoyancy, which violently lifts the water even faster, drawing up even more water from below.
It creates a massive underwater chimney effect.
It does. It goes from zero to a self-sustaining runaway eruption column in a matter of seconds. The technical term for this phenomenon is an ambiorictic flow.
Ambiorictic flow.
The column of bubbly, gas-choked water rapidly accelerates upward through the layers of the lake, entirely destroying the stratification. It finally explodes violently out of the surface of the lake at incredible concussive speeds, forming that churning 100-meter-high fountain the surviving witnesses saw in the moonlight.
And as millions of tons of water are violently displaced by the rising gas column, it creates that 25-meter tsunami wave that scoured the shoreline.
But the final, fatal physical transformation happens when the gas actually breaches the surface. As this massive volume of highly compressed carbon dioxide hits the open atmosphere, it violently expands.
And expanding gas gets cold.
Right, according to the laws of thermodynamics. Rapid expansion causes rapid cooling. So this gas, which is already naturally heavier than oxygen and nitrogen, becomes incredibly cold, making it exceptionally dense.
Wow.
It physically slumps down over the lowest point of the crater rim and flows down the valley walls like a silent, freezing, invisible avalanche of death.
It is a truly breathtaking, elegant mechanism of destruction, the Earth simply equalizing pressure. But while the international scientific community was marveling at the discovery of this new geological phenomenon, the human reality on the ground was an absolute, unmitigated nightmare.
We can't lose sight of that.
The aftermath of Lake Nyos deeply exposes the profound, tragic vulnerability of human systems in the face of natural hazards.
Right.
We have to talk about the survivors.
Yes. Let's shift our focus to the socioeconomic disaster that unfolded over the following days, months, and decades. You have 4,434 people who survived the gas, but who have just lost literally everything.
Everything they owned.
They've lost their families, their neighbors, their livestock, their crops, their entire ancestral livelihoods. They're completely displaced, traumatized, and forcibly moved by the government into 7 hastily constructed temporary resettlement camps with names like Bubua and Kimbi.
And the disaster management response to this crisis, it was, frankly, deeply flawed and chaotic. We really have to look critically at how both the Cameroonian central government and the wider international community handled this recovery effort.
It is a textbook, tragic case study of how administrative over-centralization can cause immense secondary harm on the ground. The entire emergency response, the logistics, the funding, and the crucial decision-making processes were entirely concentrated in the nation's capital city, Yaoundé.
Yaoundé is over 500 kilometers away from the Lake Nyos region. It's a completely different geographic and cultural world.
Exactly. You have federal bureaucrats sitting in offices in the capital making sweeping, life-altering decisions about the relocation of thousands of rural displaced farmers and nomadic herders without any meaningful consultation or communication with the people actually affected by the tragedy.
The central government completely ignored the local traditional authorities. In this specific region of Cameroon, society is deeply organized around traditional chiefs known as fawns.
The fawns.
The fawns hold profound cultural, spiritual, and highly practical administrative significance regarding land use, property rights, and social cohesion. By entirely bypassing the fawns and issuing top-down edicts from the capital, the government created a massive vacuum of trust and local authority.
And that administrative arrogance led directly to severe, predictable land disputes. You cannot simply take 4,000 deeply traumatized people from one area and randomly drop them onto new plots of land miles away without carefully navigating the existing tribal boundaries and agricultural rights of the people who already live there.
That's a recipe for disaster.
It immediately sparked intense, sometimes violent ethnic tensions between the displaced Neos populations and the host communities near the resettlement camps. The host communities felt their land was being stolen, and the displaced communities felt they were being imprisoned in hostile territory.
But the mismanagement wasn't just administrative and cultural, right? It was heavily financial. In the immediate wake of the terrifying images of Neos being broadcast globally, the international community rallied.
Money poured in.
Roughly 680,000 euros poured into Cameroon from donor nations like France, Japan, the United States, and various international NGOs. In 1986, in rural Cameroon, that was a massive, life-changing sum of money meant specifically for emergency relief and long-term rebuilding.
Which naturally demands the difficult question: where did all of that money go? Why were the camps still suffering decades later?
That is the most tragic part of the human story here. To truly understand it, you have to look at the macroeconomic context of the time. In 1986, the state of Cameroon was plunging headfirst into a severe, crippling economic crisis. Global commodity prices, particularly for oil and agricultural exports, were crashing.
Oh, I see.
Harsh structural adjustment programs mandated by international financial institutions were looming over the government, and the state's internal finances were in absolute disarray.
And we know from history that in environments of extreme economic desperation and institutional instability, corruption does not just survive, it thrives.
It certainly did in this case. There was rampant, deeply systemic embezzlement of the international relief funds. The money that was explicitly intended for building permanent housing, for replacing the thousands of lost cattle that were the lifeblood of the local economy, for building basic health clinics and education infrastructure in the resettlement camps, simply vanished.
Stolen.
It was siphoned off into the private pockets of corrupt officials at various levels of the bureaucracy.
Leaving the survivors entirely abandoned, languishing in what were supposed to be temporary emergency tents and shacks for decades. Even 30 years after the eruption, journalists and researchers still documented reports of families living in dense clusters of small, inadequate huts, struggling with generational poverty, severe lack of clean water, and living far away from basic medical care and functional schools.
And the psychological and spiritual toll of that displacement is immense and ongoing. These communities are entirely cut off from their ancestral lands. For many of these people, their connection to the land around Lake Nyos is not just economic. It is deeply tied to their ancestors, their history, and their core spiritual identity.
Right, it's their home.
They desperately want to return home, even knowing the terrifying geological risks that still linger in the dark waters of the lake.
It creates a heartbreaking, almost impossible paradox for these families. The burning desire to return to a patch of earth that literally suffocated their loved ones, simply because the alternative, living in a state of perpetual, impoverished, marginalized displacement, has become completely unbearable.
It's awful.
It profoundly underscores a fundamental rule of geography. A natural hazard, like a gas eruption, is merely a physical event. A disaster is defined by the failure of human systems to protect, support, and adapt human life in the face of that event.
I couldn't agree more, but I do want to pivot because the scientific community did not abandon Lake Nyos. While the socioeconomic recovery utterly stalled in bureaucratic purgatory, an incredible, unprecedented coalition of scientists and engineers mounted a massive effort to literally defuse the killer lakes.
This brings us to the active mitigation phase. The realization among the scientists monitoring the lake in the years following the disaster was stark and terrifying. The magma chamber deep below the crust hadn't stopped.
It was still leaking.
It was still actively pumping roughly 4,400 tons of pure carbon dioxide into the bottom of Lake Nyos every single year. The lethal gas was actively recharging. The immense pressure was building all over again. The seltzer bottle was being forcefully repressurized.
It was a literal ticking time bomb. The data show that by the late 1990s, the gas saturation levels in the deep water were rapidly approaching the exact same critical levels seen just before the 1986 disaster.
It was going to happen again.
If nothing was done, it wasn't a matter of if the lake would erupt again, but when. Something had to be done to intervene.
Enter the Neos Manon degassing program, often referred to as NMDP, and later augmented by the CETREPS project. This was a truly massive, high-stakes international collaboration involving brilliant French volcanologists, Japanese geochemists, and American engineers.
A global effort.
Their stated goal was entirely unprecedented in human history: to intentionally, artificially induce a controlled limnic eruption in order to safely vent the millions of tons of gas into the atmosphere before nature decided to do it catastrophically.
When I first read about the engineering solution they came up with, I honestly couldn't believe it. The concept is brilliantly, elegantly simple on a whiteboard, but it is absolutely terrifying to execute in reality.
Terrifying, the right word.
They designed high-density polyethylene pipes. These pipes were massive, 203 meters long. The plan was to raft these massive heavy pipes out to the exact center of this deadly lake and lower them vertically, straight down into the highly saturated monoamine layer.
I want to pause right here and deeply interrogate the immense risk these engineers were taking. When Michel Hobwalks and his team first proposed this specific intervention, the skepticism and sheer terror from the broader community must have been overwhelming.
Oh, I'm sure it was.
Think about it. You have a lake that is a known hair trigger bomb that just killed 1,700 people, and your scientific solution is to sail out into the middle of it on a small plastic raft and intentionally hook it with a massive 200-meter pipe to pull the highly explosive deep water up to the surface.
Yes, it sounds like madness. You're poking the bear.
Could this artificial intervention, this heavy mechanical disturbance in the water column, accidentally trigger the exact catastrophic rollover they were trying to prevent? If the heavy pipe swung and vibrated violently during installation, or if the water column was disrupted by the initial pumping, could they have set off another 1.2 million ton release of suffocating gas while the entire engineering team was floating directly on top of ground zero?
It was a very real, very massive fear. There was genuine, mathematically sound speculation that the sheer act of degassing could inadvertently destabilize the precarious stratification of the lake.
The stakes couldn't have been higher.
The risk was so high that when the French team finally went out to test the very first prototype pipe in 2001, the Cameroonian military was brought in. They mandated that every single worker on the raft wear emergency oxygen tanks and masks at all times. They knew the risks. They knew they could all die in an instant.
So mechanically, how does the degassing pipe actually work without blowing up the lake and killing everyone on the raft?
It is genius because it harnesses the exact same deadly physics as the disaster, but confines it within a controlled environment. They install a mechanical pump at the very top of the polyethylene pipe. When everything is set, they turn on the pump, and it gently begins to pull the deep, gas-heavy water up from the bottom of the tube,
Lifting it to a shallower depth, thereby lowering the immense hydrostatic pressure acting upon that specific parcel of water inside the pipe.
Exactly. Inside the confined, narrow space of the pipe, the pressure drops as the water rises. The carbon dioxide obeys Henry's law. It exsolves into tiny bubbles, and those bubbles immediately create massive buoyancy.
Like the chimney effect we talked about.
Within minutes of turning the pump on, the rapidly rising bubbles generate so much intense upward lift that they don't even need the mechanical pump anymore. They turn the motor off. The pipe becomes an entirely self-sustaining fountain driven purely by the Earth's pressure.
It creates an artificial, completely controlled ambiorectic flow.
Yes, it rockets a massive frothing mixture of water and gas 50 meters straight up into the air out of the top of the pipe at speeds exceeding 100 miles per hour.
Wow.
Because it is a highly controlled, localized spray venting directly at the surface, the carbon dioxide rapidly mixes with the ambient air and safely, harmlessly dissipates high into the atmosphere rather than forming that dense, lethal, low-hanging cloud.
It is an absolutely incredible feat of engineering, taking the problem's own deadly physics and turning it into the solution. And what were the measurable long-term results of this highly dangerous intervention?
It was a staggering, resounding success. By 2012, after years of testing and securing more funding, they had successfully added multiple pipes to both Lake Monon and Lake Nyos. At Nyos specifically, the total volume of dissolved carbon dioxide in the lake was reduced by a massive 40%.
That's huge.
Dropping from a terrifying 710,000 metric tons down to a much safer 425,000 metric tons. Eventually, they added enough pipes to reach a perfect steady state where the artificial degassing rate safely bleeding gas into the sky perfectly matches the natural magmatic recharge rate bubbling up from the Earth's mantle.
They effectively engineered and installed a mechanical exhaust valve on a volcano.
They absolutely did. It is a triumph of science. But just as we think the beast is finally tamed and the valley is safe, we have to look closely at the geological survey data. Because Lake Nyos harbors another entirely different, incredibly apocalyptic threat that has nothing to do with gas.
You were referring to the natural dam.
Yes, the entire northern edge of Lake Nyos is impounded not by solid bedrock, but by a natural dam made of highly fragmented volcanic rock known as pyroclastic material.
Right, it's just loose rock and ash.
This dam is what holds the lake in the crater. It is only about 40 meters thick and 45 meters wide at its narrowest, most fragile point, and structurally, it is incredibly weak.
Let's deeply explore the catastrophic implications of a failure here, because this isn't just about some localized flooding washing out a few roads.
Far from it. Geologists have been warning for decades that this natural dam has been rapidly deteriorating. Constant water seeping through the porous rock, combined with heavy seasonal overflows during the August rains, have deeply debilitated the structural integrity of the wall.
It's crumbling.
If this 40-meter-thick wall of loose rock finally crumbles under the immense weight of the lake, it will instantly release 60 million cubic meters of water.
Good Lord.
That colossal wall of water will surge violently down the valleys, wiping out everything in its path, eventually crossing the international border into neighboring Nigeria. Current estimates suggest a dam breach could wipe out up to 10,000 people in the flood zone alone.
A horrifying death toll from the water itself. But the flooding is only the first phase of the catastrophe. We have to apply our physics again. What happens to the delicate, pressurized ecosystem of the lake itself when 60 million cubic meters of water suddenly, violently vanish from the surface?
The actual water level of the lake would drop instantly by at least 40 meters.
Which means the heavy blanket of water providing the downward hydrostatic pressure on the deep, gas-saturated layer is instantaneously, permanently reduced by roughly 4 full atmospheres of pressure.
Exactly. If that natural dam breaks, the sudden massive loss of top pressure would act like ripping the cap entirely off the seltzer bottle.
Good.
It would absolutely definitively trigger another massive, uncontrollable limnic eruption of whatever gas remains in the deep water. It would be an unprecedented dual disaster. A catastrophic, region-destroying flood, followed immediately by a massive, suffocating cloud of carbon dioxide rolling over anyone who managed to survive the water.
It creates a staggering geopolitical nightmare as well. You have a massive natural disaster originating inside the sovereign borders of Cameroon, aggressively annihilating downstream communities in the sovereign borders of Nigeria. The diplomatic and humanitarian fallout would be incalculable.
Truly.
How on earth is this dual threat being addressed today?
The mitigation is twofold, and it requires constant funding. First, the ongoing continuous degassing through the pipes ensures that if the pressure does suddenly drop due to a dam failure, there is significantly less dissolved gas available in the water to exsolve and erupt.
So reducing the payload.
Right. Second, major civil engineering works have been undertaken to artificially reinforce that weak natural dam. They are specifically using advanced techniques like massive jet grouting, injecting high-pressure concrete directly into the weak pyroclastic material to bind it together and stabilize the wall. But it requires constant, unrelenting vigilance and maintenance.
Which leads us directly to the highly advanced monitoring systems currently in place. You cannot just fix a highly volatile, complex system like Lake Nyos with a pipe and some concrete and walk away.
No, you can't. They rely on incredibly sophisticated, continuous remote technology now. Through the Japanese-led SATREPS project, scientists installed automated high-tech observation buoys floating directly on the lake.
That makes sense.
But here is the major engineering challenge. Measuring dissolved carbon dioxide concentrations at extreme depths of 200 meters is incredibly difficult. If you try to pull a physical sample of water up to the surface to test it in a lab, the pressure drops as you haul it up, and all the gas violently escapes before you can measure it.
It's the observer effect in fluid dynamics. The act of measuring it destroys the sample.
Exactly. So how do they accurately measure the deep gas concentrations in situ without disturbing the water?
They use a combination of CTD probes, which stands for conductivity, temperature, and depth sensors, and they combine those with highly sensitive sound speed sensors.
Ah, acoustic monitoring. This is fascinating physics.
They're using sound because the amount of dissolved carbon dioxide physically changes the density and the compressibility of the water itself, which in turn drastically alters the speed at which acoustic sound waves travel through that medium.
Wow, that is brilliant.
A high concentration of dissolved CO2 measurably increases the speed of sound through the water. But interestingly, it does not contribute to the electrical conductivity of the water. By continuously measuring both the speed of sound pings and the electrical conductivity, algorithms can mathematically extract a highly accurate, continuous 247 profile of the exact CO2 saturation at every single depth of the lake.
And this all beams to a satellite.
Right, this data is bounced directly off communication satellites, allowing scientists sitting in laboratories in Yaoundé and Tokyo to monitor the lake's internal breathing and pressure in real time.
That is a truly brilliant application of indirect scientific measurement. But while we can rightfully celebrate the incredible stabilization and monitoring of Lake Nyos and Lake Manon, we are forced to cast our eyes further south, down the African continent, to a geopolitical and geological situation that makes Lake Nyos look like a minor dress rehearsal.
We absolutely have to talk about Lake Kivu.
He-
Lake Kivu sits directly on the heavily populated international border of Rwanda and the Democratic Republic of Congo. And the sheer scale of the geological threat here is almost too large for the human mind to easily comprehend.
It truly is. Let's do a scale comparison. Lake Nyos, the lake that killed 1,700 people with a cubic kilometer of gas, has a surface area of about 1.5 square kilometers. Lake Kivu is roughly 3,000 times larger.
3,000 times.
It is an immense inland sea. And just like Nyos, it is meromictic. It is incredibly deep, and because of the equatorial climate, it is stubbornly thermally stratified. But Kivu doesn't just hold carbon dioxide in its dark depths.
No, it holds methane. Inconceivably huge quantities of highly combustible explosive methane gas, chemically known as CH4.
Which is terrifying.
This methane is constantly being generated by complex biological processes, bacteria breaking down organic matter deep in the lake bed, accumulating right alongside the magmatic carbon dioxide seeping up from the rift below.
The numbers are terrifying. Geologists estimate there are currently 300 cubic kilometers of dissolved carbon dioxide and 60 cubic kilometers of explosive methane trapped in the deep, pressurized waters of Lake Kivu. And to make matters infinitely worse, it sits squarely in one of the most highly volcanically and seismically active regions on planet Earth, the East African Rift.
Let's connect this terrifying data to the bigger picture of human habitation. Imagine a catastrophic limnic eruption occurring at Lake Kivu. You wouldn't just have an invisible, heavy cloud of suffocating carbon dioxide rolling over remote farming villages.
Huh.
You'd have a massive, unprecedented eruption of explosive methane gas being released into the atmosphere simultaneously.
If a significant seismic event, a major earthquake tearing through the rift, or a direct lava eruption from the highly active nearby volcano Mount Nyiragongo were to violently trigger a massive rollover in the layers of Lake Kivu, the resulting gas cloud wouldn't just silently asphyxiate the population. If that massive cloud of methane found a single spark, a cooking fire, a car engine, a lightning strike, it could violently ignite. We are talking about a region where millions of people are living directly on the shores of Lake Kivu, in densely packed major urban centers like Goma in the DRC and Gisenyi in Rwanda.
The implications are, quite literally, apocalyptic. The potential loss of life wouldn't be measured in the thousands. It could easily be measured in the millions. Millions of human lives hang in the delicate balance, entirely dependent on the fragile thermal stratification of a volcanic lake. It aggressively demands the question, are the hard-won engineering lessons learned at Lake Nyos actually being applied to diffuse the gargantuan threat at Kivu?
They are, but the sheer unfathomable scale makes it incredibly complex and dangerous. The Rwandan government is currently undertaking massive commercial projects to actively extract the methane from the deep water to use it for national power generation.
Oh, that's clever.
Yeah, this extraction acts as a highly beneficial form of industrial degassing, slowly lowering the pressure. But the sheer volume of volatile gas remaining in the lake is a massive looming shadow over the entire geopolitical stability of the Great Lakes region of Africa.
It brings us to a grand synthesis of everything we have exhaustively discussed today. We have traversed complex geology, isotopic chemistry, advanced fluid dynamics, and the deep tragedies of human sociology and corruption.
We've covered a lot of ground.
If we step back and connect all of these seemingly disparate dots, a profound and unifying reality emerges about our relationship with the planet.
And what is that ultimate reality?
That natural hazards, whether it is a silent buildup of magmatic gas beneath a lake, the delicate thermal stratification of a massive body of water, or a weak, deteriorating pyroclastic dam, or simply the blind, amoral mechanics of the Earth. The Earth is constantly shifting, pressurizing, and releasing energy.
Right, the Earth doesn't care about us.
These physical events only become disasters when rigid, unprepared human systems violently intersect with them.
Yes, exactly.
The true tragedy of Lake Nyos wasn't just that the water obeyed Henry's law and erupted gas. It was that vulnerable communities were living entirely unknowingly in the direct crosshairs of a loaded geological weapon.
And without the knowledge to save themselves.
And the prolonged multi-generational suffering that followed wasn't caused by the carbon dioxide. It was caused directly by human corruption, administrative centralization, and the fundamental failure of disaster management to respect local culture, distribute resources fairly, and adapt to the urgent needs of the displaced.
It is a powerful, undeniable realization. These killer lakes perfectly represent the silent, invisible accumulation of pressure in our world. We have massive geological pressure building in the deep, dark waters of Mars and Rift Lakes. But we also have massive, volatile, societal pressure constantly building.
We certainly do.
Generational poverty, forced displacement, lack of education, rampant political corruption, and the marginalization of rural communities.
And just as a seemingly trivial physical disturbance, a cold rainstorm or a small localized landslide can trigger a catastrophic, unstoppable limnic eruption in a saturated lake, a seemingly trivial political or economic disturbance can trigger a catastrophic collapse in a highly vulnerable, saturated, marginalized society.
Proactive, rigorous science, like the brilliant engineering of the degassing pipes and the continuous acoustic monitoring buoys, is how we intelligently release the geological pressure safely into the sky. But compassionate, transparent, highly decentralized, and locally informed governance is the only way we can safely release the societal pressure. We absolutely have to work to diffuse both systems simultaneously, or the disaster is merely being delayed, not prevented.
It highlights the absolute non-negotiable necessity of foresight in the modern world. We cannot simply wait and react to the rumbling in the dark. We must dedicate ourselves to understanding the complex, intertwined systems that surround us before they inevitably reach their critical, catastrophic saturation point.
Which leaves you with a final, profound thought to mull over as we conclude. We've seen today how a serene, incredibly beautiful mountain lake was secretly holding a lethal breath, silently waiting for a single, trivial disturbance to trigger a runaway chain reaction of mass death. As you step away from this and look around your own environment, your local community, the physical infrastructure you rely on, the complex global economic and political systems we are all deeply tethered to, what other hidden, highly saturated systems are currently holding their breath?
It's a sobering question.
Where is the invisible, unaccounted for pressure building in our world today? And who exactly is monitoring the dark depths to ensure it doesn't quietly reach the breaking point? Thank you for giving us your time today. If you found this exploration valuable, please like, share, and subscribe to the channel. Check the description below for reference links and more information. Until next time, keep elevating your mind.
Aleatory Podcast.